So if we start with OSI model, means what is the mean of OSI model and why we have to need this OSI model. So if we talk about the OSI model, so OSI model means what? OSI means Open System Interconnection model, and it is developed by the ISO. ISO means International Organization for Standardization. And in 1984, ISO developed this model. So if we talk about before 1980, means before 1984, if we talk about, so that time only two companies were available in the market, that were HP and IBM. So that time only two manufacturers were there, so HP and IBM. So that time what happened, actually, if HP want to make the connection, if HP want to make the network with this IBM machine, so they couldn't make this type of connection. Means if you want to create the network, if you want to make the network, that time you have to need the same manufacturer, because that time they use on model, on network model, to create the networking device like NIC and everything. Right. So that time what happened, if you have HP devices, HP laptop or HP desktop available in your company or in your network, so only you can compare with the HP laptop or HP computer. You can't compare with the IBM. Or if you have IBM, so you can only compare with the IBM PC. You can't compare with the HP PC. So for that we have to need at least one same model for every company, because if same model will be there, so that time all the devices, all the manufacturer devices can compare with each other. So what happened that time, OSI model, we developed the conceptual model for this. Means if you will see here, so it is a 7-layer conceptual model. Right? Conceptual means what? It is only the concept where everything is defined, means how to data transmit from source to destination over a network. If you have two devices available in your network, like if I will create here, if you have two devices available in your network, which we simply use. Suppose if you have this PC and you want to send some data from first PC to second PC, and when you will send the data from first PC to second, we will send the data and we will receive the data on another end on another PC simply. But in backend, how this data will be travel? So that is the OSI model. In this OSI model means we have 7 layers. Means in that 7 layers, that is defined how to data transmit. So that if we will face any issue there, so that time we can understand, okay, here is the issue on this layer or on this device or on this protocol or on this software, we have the issue. So we can understand that thing. So for that we have to need one model. So that is ISO model here. If I tell you ISO model, so here we have 7 layers. Okay, can anyone tell me there are 7 layers?
Um, I think physical layer, then data link layer,
Okay, physical,
then
then interlink,
network layer,
okay, network,
Transport
then
layer, session layer,
transport
Transport.
layer.
presentation layer, and application layer.
okay, perfect, transport, session, presentation, and the last application. Right, so these are the 7 layers of this OSI model. So if you will see here, this OSI model layer, so here you can see we have this model layers, physical layer, data link, network, transport, session, presentation, and application. And here is the diagram. Here we have one sender and one receiver available. This is my first PC, and that is a sender, and that is a receiver PC. So how this data will be travel? When you will work on your sender side, means you are working on a software. Because if you work on the network, that time every time we will work on any software. Like in mobile, if we give the example of the mobile. So in mobile, when we use the network, that time we use WhatsApp, Facebook, Google, right? So every time we use any software there, so software means application there. So every time when you work on the sender side, you are working on this application there. So suppose we are using this application, and by this application we send the data from first PC to second PC. That data will be transferred to the second layer, that is presentation layer, and then it will transfer to the session layer, then transport layer, then network layer, then data link, then physical. Now on this physical layer, your data will travel on this media. Media means your wire. By this wire, your data will be transferred to the second PC, and on this second PC, on this receiver side, data will be received on this physical layer, and then it will transfer to the data link, network, transport, session, presentation, and on another side, on this receiver side, this data will be received on this application layer. Means receiver can see the data on this application for what you just send that data. So that is the OSI model layer. And if we categorize this layer, so here you can see on upper side this application layer, this presentation layer, this session layer, these called as upper layer or software layer. Because on these layer, application, presentation, and session, every time we use some software, right? I will everything behind you means what's the mean of this application and how data will travel on this. But for now, if we categorize these layers, so these upper side layers known as upper layer or software layer, and here lower side layer network, data link, and physical layer known as lower layer and hardware layer. Because on these layers we have some hardware, and this transport layer is known as middle layer. Right, so we have these seven layers. Okay, if you have any doubt in these layer or layer, so just let me know. After that, we understood this means we have seven layer of OSI model, and we categorize also that layer means upper side layer is known as software layer, and lower side layer is known as hardware layer, and the transport layer is known as middle layer. Now, if you will see after that, here we have some data unit. Data unit means what? We have the physical layer, data link, network, transport, session, presentation, and application. So every time if you will see here in physical layer we have this data unit means data is in bits form. On data link layer data is in frame form. Network layer data is in packet form. Transport layer data is in segment form. And on upper side layer this session, presentation, and application data is in normal data form. Right. So why we have this different data units? So if we take the example of that, so I will give you one example. Like suppose if you want to uh, send something by a courier service from one location to another location. So how we will transfer? Suppose we have this location, we have one location and that is another location, and that is suppose Delhi. From Delhi, you want to courier some data from this Delhi to Mumbai location, right? Mumbai location. So what you will do? Suppose I want to send my mobile phone. So firstly, normal mobile is in normal format, normal data format, and then what I will do? Then I will means pack that in a box, pack that mobile in a box, and after wrapping in a box, the data format is changed. That is now not in a normal mobile format. Now that is a box. So that is format is changed. In simple, we can say suppose normal data is that is a mobile in data here. That is a mobile, and we pack that into another format. That is my web box in which I just put that mobile phone and I just pack that box. So that is my segment. After that, when I will transfer to the or when I will give that box to the courier office. In courier office, they will again pack that in another format in a box or in a container type. So that will be the package. Again, that is changed. After that, they will send this to the Mumbai location, and in Mumbai location, they will again unwrap and again pack in another format. Suppose that is frame format, and in Mumbai location, there is multiple location or multiple areas available. So for that area, they will pack again for a specific area, and they will give to the courier boy for that area. So that will be the another format like this bit. So for that, if you will see here, so when we work on application, on any application, so that time our data is in normal format in data form. Suppose you want to send the music file, so that music file will be in the normal format. After that, it will transfer to the next transport layer. In transport layer, the data will be changed into this segment because here we have some protocol like TCP, UDP, that protocol. So they will change this data into another format in this segment format. After that, this data will be sent to the devices. And here on network layer, we have router. Right, as we discussed, our lower layer, network, data link, and physical layer is known as hardware layer. So that means we have some hardware available on these layers. So on network layer, we have router works, And on data link layer, we have switch work. On physical layer, we have cables and connector. Cables and connector works on this layer. That means when a router will receive the data, so router will convert that data format into this packet, and after that, that router will send the data to the frame to the data link layer, and on this data link layer, we have the switch. So switch will convert the data into this frame format. After that, data will be travel on the cable and on the connector. So on that cable and connector, data will be transferred into bits format. That's so that we have different types of data units available. We also have to understand that okay, when we work on the application, data is in normal format. When data will be transferred to the any other like cable, so on cable we have the data in bits format. Means on the connector we have data in bits format, and on switch we have data for unit is frame. On router, data unit is packet. So we have to understand that concept also. Okay, after that, our first layer. If you will see here on first layer, our first layer is physical layer. Physical layer. Because if you will see here, we have in this series we have first layer is application. But according to ISO in OSI model, first layer is start from lower side to upper side. That means our first layer is physical always. Means when you will define anywhere like the OSI model layers. So first layer you have to tell physical layer. Second layer data link. Third is network, transport, session, presentation, and the last layer is application. So the first layer is physical layer. Here you can see according to ISO also, this is the first or bottommost layer. Right? ISO also says that. That is the first layer and bottommost layer of the OSI model. It will receive the data from data link layer, from the upper layer on the sender side, and transmit the data to the data link layer on the other side. It uses cable connector to make a connector as we discussed. On this physical layer, we have cables and connector. Now, what is the responsibility of this layer? So, if we talk about the responsibilities, first is encoding. Encoding means what? Encoding means it converts bits into signal and vice versa. So, as we discussed, here we have cables and connector, right? Connector available on your system. So, till here we have the data is in bits format, and when data will be travel on this cable, so data will be converted into the signal form in signal form. And again on other side, when data will be received on this connector on this adapter, so that time data will be again convert into or convert from the signal into this bit format. That is called encoding. That is the first responsibility of this physical layer. Second is transmission rate. Transmission rate means on this layer, or we can say this layer defines the data transmitting speed. Means what will be the data transmitting speed? Who will decide that? This layer will decide. Why? Because on this layer we have cables and connector. And if you ever heard, so on this cable and connector, our data transmitting speed depends. Right? Because we have multiple types of cable. We will discuss in next chapter where we have about the cable. So we have multiple types of cable like twisted pair cable, and we have fiber cable also available. And in twisted pair we have multiple categories available: Cat 1, Cat 2, Cat 6, Cat 8. So on that category and on that type of cables, that speed depends. So that means on this physical layer speed will decide. And the second thing on this connector also. In suppose if your cable support 100 Mbps, 100 Mbps your cable support, but your connector supports only 10 Mbps. That time what will happen? Your cable will transmit 100 Mbps, but your system or your connector will receive only 10 Mbps. So on this cable and connector means on this physical layer, your speed depends. Okay, next is transmission mode. Transmission mode means defines the direction of data flow. Means it will decide the direction of data flow. Means what will be the direction or which type transmission mode will be used there. Okay, so if you see a transmission mode, so here you can see. we have three types of transmission mode available. Number one is simplex. Simplex means what? Only one device can be sender and another one can be receiver. If you have two devices. So because we for the network we have to need at least two devices if you want to make the network. So that time if your network works on simplex, that means your first device or your one device can be the sender and another one can be the receiver. Here we have this example, television and remote. Television and remote means what? In that we have the network because by the remote we send the data to the television, television receives the data. But when you will see there, so television only can receive the data and remote only can send the data. Television can't send the data and remote can't receive the data. That means that works on the simplex mode, right? And we have another types of things also available like any remote car or any remote device. We have that. Half duplex means what? We have two devices and both devices can send and receive the data but not at same time, right? Here we have the example hub and Bluetooth. If you didn't heard about the hub, no issue. You have the Bluetooth, right? I think everyone knows about the Bluetooth. In Bluetooth, when you send the data from your first device, like if we take the example of mobile phone, so when you send the data from your first mobile to second mobile, that time second mobile can't send the data to first one or any another. When this transmission will complete, after that you can transmit the data from you can transmit the data via second device. That is called half duplex. Full duplex means what? Both device can send and receive the data at the same time. We have the example switch and mobile phone also. And I think everyone knows mobile phone. So mobile phone means what? When you send the data from first mobile to second mobile, that time second mobile can also send the data. And we have the good example. If you are making a call with another one, that time what will happen if you are saying something like "Hello, I'm doing this" or anything. If you are saying there, that time second person can also interrupt you, can also send the data at the same time. Right? So that is called full duplex. I will also give you the example for hub and switch because we have the next means we have one topic also available for networking device. There I will define everything, how this hub works or switch works. But for now, hub duplex and full duplex. Is that clear for everyone? Or if anyone has any doubt, so just feel free to ask. Okay, so that's about this physical layer. Now next layer. So next layer is data link layer. So data link layer means what? This is the second layer of OSI model, as we discussed earlier also. There is the second layer. It receives the data from its upper layer. Upper layer is network, means it will receive the data from the network layer. Then it will convert the data into frame format. As we discussed, on this layer, on this data link layer, data unit is frame. So it will convert that data into frame and then it will attach header and trailer and forward the data to the physical layer to the lower layer. At the receiver end, it will receive the data from the physical layer, from the lower layer, and it will remove the header and trailer which attach from first side and forward the data to the network layer to the upper layer on the receiver side. Now here we have this header and trailer box. So header means what? Header contains the 48-bit MAC header of the sender and receiver. Means what? On this layer, your data will be converted into frame format. Suppose that is frame, and on one header will be attached on this frame, and one trailer will be attached. Header means here we have the address, MAC address, media access control. Right? That is the physical address of devices by which your device or your switch will means understand that okay, on which device I have to send the data. You send the data from first to third one or to the fourth one. So it will decide according to this MAC address. So here sender and receiver, both of the MAC address is available. Trailer means what? Trailer is used for the error control. Means it will control the error. And here the data unit frame. The maximum size of this frame can be 1518 bytes. And that means here you can see that is normal data. In normal data, what we have the data available in bits format, right? Or we can say binary format. If you ever heard, our system, our computer only understood this binary format. And in binary, we have bits. We have 0 and 1. So that is called bits. And we have this bytes unit. Bytes unit means what? One byte is equal to 8 bits. So in this frame also we have this same data. Only the mean is they pack one packet of this frame. That is called here frame. 15, 18 bytes of data. And here one header and one trailer available. And responsibilities of this data link layer, framing means it will convert your data into frame. It will do the framing. Second is physical addressing. Here we have this header. In header we have this MAC address. That is called physical addressing. Error control. So here we have this trailer. So it will control the error. Right? So that is the meaning of data link layer. Okay, so is that clear for everyone? Now after that, the next thing is network layer. If you see here, so network is that is the third layer of OSI model. It receives the data from the transport layer, from the upper layer, and it will convert it in the packet and forward into the data link layer at the receiver, and it receives the data from the data link layer and forward to the transport layer. That means if we talk about, so here we have physical, data link layer, network layer, and transport layer. And on another side also we have transport layer, network layer, data link layer, and physical. Right. So on this side, on the sender side, this network layer will receive the data from the transport layer, and then it will forward this data to the data link layer. On the other side, it will receive the data from the data link layer, and then it will transfer this data to the transport. Then it select and manage the best logical path for data transfer between nodes. Means what is the use or what is the responsibility of this layer is, so it will select and manage the best logical path. Best logical path means what? Suppose if we take the example of network. So suppose if we have this network, so if you want to create one network, what you have to need? You have to need some PC. We have this PC, and I want to send that data to another network, and then we have multiple PC available. That means we have to need one multi-port device where multi-port are available. So that is switch here. So we will connect all the devices with switch. That is switch. And on this side also we have to need switch. Right? Switch has multiple responsibilities, but in simple we can say switch is a multi-port device. Because if you have only two PC, that time you can connect these two PC with each other via cable if you want to create the network. But if you have multiple PC like 10 PC, 5 PC, or 20 PC, so that time you have to need one multi-port device. Because in your PC, only one NIC available. And if you want to expand that, so there is a limit. You can expand 2, 3, 4. You can't expand like 50 or 100. So for that, we have to need switch. That is multi-port. Then we have to make the connection with different network, because here we have this different network. That is the different network, and that is our network. We have to make the connection with that. So for that, we have to need one router, because router means what? Router is used to make the connection with the different network. So we have to need one router. So we will connect router. So suppose I just connect here router. That is our router, and one router I will connect here. After that, I have to need to connect these two routers with each other. So here is the connection. After that, what I have to do? That is the logical path in backend. Because in this picture, I connect these two routers with each other normally by a cable. But suppose you are in Delhi and second network is in Mumbai and third network is in Hyderabad. So that time you can't use your cable. That time you have to need your internet, right? Because internet is everywhere. So we can use that internet to deploy our packet from one location to another location. But for that, in backend, we have to need one logical path. By that logical path, our network will be connected. Our devices will be connected. So to manage that logical path means how your data will be transferred from one location to another location. Because on the internet, we have multiple network available. We have lots of network available. So this network layer will do that. And for that, it will use this router. And on that router, we have this concept routing. This router. Right? We will also discuss in this training about this routing, about this everything. But for now, routing. Routing is the process to find and select best way. It is the process. Means by which we will define that okay how your first router will be connect from the uh, another location like from Delhi to Mumbai or from Delhi to Hyderabad, how it will connect. So this routing will decide that. By routing we will define that. Logical address means what? On logical addressing, as we discussed, that is IP address. So via IP address, your data will be transferred from one location to another, or from one location or from one device to another device by this logical address. Internetworking means what? To connect two or more networks. As we discussed, router is used to connect two different networks. So if you have two or more networks, so to connect that network, that is called internet. Two different networks if you connect, that is internet. All the responsibilities belongs to this network. Okay, so after this network layer, next layer is transport layer. So transport layer means what? Transport layer is the fourth layer of OSI model. First thing, that is the fourth layer of OSI model. It receives the data from the upper layer. So upper layer is session layer. It will receive the data from the session layer, and it will convert them into known as segments. Right? It will convert that data into segment form. Pass this data unit to the network layer, to the lower layer, and ensure that all the pieces arrive correctly at the other end. Means that is the responsibility of this layer to ensure that means all the pieces which is sent from the first side, from the first PC to second PC, so that pieces arrive correctly on the other end or not. It will ensure that. So if you will see here responsibility. So first is service point address. Service point addressing means what? The responsibility of the transport layer is to transmit the message to the correct process, known as service point address. Correct process means what? It will means that is also known as we can say that is also known as port addressing. In simple, we can say if you ever heard we have logical port. Right? Logical port means what? If you ever heard for HTTP we have 80 number port. We have for HTTPS we have 443 means in backend. Because suppose if we give the example, if you want to connect two devices, so for that we have to need port. You have first device, you have second device, you want to connect, so you have to need one port here. By this port, you will connect your media and then you will connect with another piece. There also we have to need this. Right? So that means we have to need port here. That is called physical port. But in backend, but you are when you are not means connected physically with another device, that time you have to need logical port. Logical port means as we discussed, suppose you are available in another location in Delhi and I am available in Mumbai. So that time what do you have to need? You have to need one logical port by which we can make the connection. So for that, for every protocol, we have one port number. For every protocol means what? For every protocol we can say we have around the group of rules. We have set the rules. So for suppose you want to use web server. For web server, if you want to deploy this web server, so for that we have to need this protocol HTTP. If you want to take the remote of any other machine, so for that we have protocol telnet, we have protocol SSH. That is the protocol. Means for everything we have some protocol by which we will use that service, we will use that application, or we will use that service. Or in simple, for every application also, we have to need some protocol. If you want to deploy that application, if you want to use that application over the internet, so that time we have to need some protocol. And for that protocol, we have port number, logical port number, by which over the internet, your device or your application will connect with the correct process, with the correct application. Suppose we are using WhatsApp. When I will send one message from my device, from my mobile to another one. So that time what I have to need? First thing I have to need the mobile number on which I will send the data, on which I will send the message. Second thing I have to need means second thing for application. To application that is need, that is port number. When I send the data from the WhatsApp, so it will also receive on the WhatsApp. So for that, there is one port number. That is logical port number. So this layer, this transport layer will ensure that when you will send the data from the specific application, so it will also receive on the same application on the other side. That is called service point address, right? So, and service point addressing means what? By which your data will be received on the correct process. Second thing is segmentation and reassembly. Segmentation and reassembly means what? When the transport layer receives the data, as we discussed on this layer, we have the data unit segment. So when it will receive the data from the upper layer, it will divide the message into multiple segments. It will divide that message, and each segment is assigned with a sequence number. It will assign sequence number on each segment. At the receiver end, transport layer reassemble the message. On the other side, on the receiver side, it will receive all the segments, and then it will reassemble that segment, and then it will create the message. Okay, that is your actual message. That is your actual data. So it will reassemble that according to your sequence number. So that is called segmentation and reassembly. Next is connection control. So that is also the responsibility of this layer, connection control. Because in its starting, as we discussed, the responsibility of this layer is to ensure that means all the pieces arrive correctly at the other end. So that means it will also control the connection. So transport layer is responsible for making a connection from source to destination. Right? As we discussed, it will control the process. It will control the correct process. So that means it will control the connection also. It will see, okay, you want to make the connection with, suppose WhatsApp, or you want to make the connection with Facebook application, or you want to make the connection with Google. So that time, what it will do, it will create the connection, it will make the connection, it will control the connection. Error control means what? The transport layer is also responsible for error control. Like data link layer, it will also control the error, and it will ensure that means your message reach at the destination without any error. So that is the responsibility of transport layer. And here we have two protocols, that is TCP and UDP, which one? Okay, after that, next layer is session layer. So session layer means what? It is the fifth layer of OSI model. It is used to establish, terminate, synchronize, and manage the connection between two pieces. Right? So that means the responsibility of this layer is to establish the connection, to start the connection, and in the end to terminate the connection, and in between to synchronize the connection and also manage the connection. And here is the responsibility. First is synchronization. Synchronization means what? So in synchronization, it will create some checkpoint. Checkpoint means what? If a system sending, here we have the example. If a system sending a file of 400 pages, adding checkpoint after every 50 pages. This is the rule. After every 50 pages, there will be one checkpoint, and that is recommend. This ensure that 50-page unit is successfully received and acknowledged. That means, in simple, suppose if you send 400 pages, so after 50 pages, means after 50 pages, there will be the acknowledgement, okay, 50 pages received successfully. That means there is no issue. After that, again, after 50 pages, there will be one acknowledgement, say, again, next 50 pages also received. Again, after 50 pages, there will be one acknowledgement. Again, next 50 pages received. So that will be called checkpoint. It is like that. If I will give you an example, there is one ground, and here one race is organized. So what will happen here? Multiple checkpoint will be there, and on that checkpoint, one uh, person will be there, and that person what will do when when player will be run in this ground. That time, that person will acknowledge that okay, at 10 people means cross this line, and 10 people cross from here also, and here one people is not able to go more and run more. So they will means they acknowledge that. So like the same, here we have the checkpoint, synchronization, right? And dialog control. Dialog control means what? This layer allows two systems to start the communication with each other in half duplex or full duplex. As we discussed in starting, so this layer will start the communication and then terminate the connection in the end and synchronize the connection and manage the connection also. That is the called dialog control. Session layer, as we discussed in starting, that layer for the that layer works on the software layer, and that is also known as software layer. Means in your software that layer works. Suppose I'm using this Cisco web. So for that Cisco web, when I means click on the start meeting, so that time in backend, this session layer, this session layer start the communication, start the connection, start this meeting. And in the end, when I will click on the end meeting, so that time it will terminate the connection. And in between, this layer synchronize the connection. Means we are connected and we are synchronized with each other. That means this layer was session. Okay, so after that, next layer is presentation. So now presentation layer means what? There is a fifth layer of OSI model, and it deals with semantics, syntax and semantics of the data between two people. So that means it deals with syntax and semantics. Syntax and semantics means what? If we take the example of any application, because that is a software layer. So if we take the example of any software, so in software we have two things. Number first is extension, like suppose if you have MP3 file for music files, that is MP3 file. And the second thing is we have the name like mm, file1 dot mp3. So here this dot mp3, this extension will decide that on which application it should be run or it will be run. It will decide that dot mp3 or dot mp4 or dot jpg or any extension or dot docx, that will decide. And here we have this file one. So here if you will compare with this syntax and semantics, so syntax means what? That is dot mp3 and semantics means what? That is metadata. Here this file one and the date of creation, date of modifying, everything. That is the semantics. So it deals with, and your data also comes in this semantics. Your data means your music file. It acts as a data translator for a network. Means this layer also acts as a data translator. The presentation layer is also known as a syntax. If you will see here the responsibility, first is translation. Translation means what? It converts the data from sender dependent format into common format and changes the common format into format into receiver dependent format at the receiving end. Because when you send the data, that is your sender dependent format. If I will, you will see this PPT file. So here we have this PPT file. That is a common format. Means that is a sender dependent format. That is my format. So here is the English word, so I can understand everything. But common format means it will convert into the common format which support your network, support your operating system, support your software. Anything. It will convert into that format. Machinery language. And at the receiving end, it will again convert into that dependent, means the receiver dependent format in this same format, in the normal form. That is called translation. Second is encryption. Encryption is the process of converting the standard transmitted information into another form. So that means encryption means what? If you are using any application, in backend there is one encryption there. And in simple, if I will tell you, so we have this Windows operating system, Windows operating. So for Windows, in backend we have MD5 encryption. And that is the encryption name. Or in simple, I think everyone knows that or everyone heard that. Means in Wi-Fi, if you are using wireless network. So there we have some encryption like WPA, WPA2, WPA3. So that is the encryption type, which will convert your normal format into some cipher text. Cipher text means suppose if you write that hello there. So when you will write hello there, so it will convert into another format like something a at the rate $1 into this format, which is not which you can't understand normally. Firstly, you have to decode that. Firstly, you have to decrypt. Then only you can understand. So that is called encryption, and that is also applicable for every application. If you are using any application like WhatsApp also, when you use WhatsApp, so that time you type in normal format, but in backend it will convert into another format, into cipher text. That is called encryption. Compression. Compression means data compression is a process of compressing the data. Means it will compress the data. We have some utilities available like in Windows. We have zip format, we have RAR format. In Linux, we have some bzip2, we have some gzip, we have xz. That is compression. And by that compression tool, your data will be compressed and the size will be decreased. And suppose if your data has 5 GB of size, that will be decreased in and decrease accordingly that compression type. If you are using zip, so that will be about 4.5 GB something. And if you are using suppose Linux compression method like GB, so that will be around 3 GB or 2.5 GB. So compression means it will compress your data so that after compression your data can be sent in that network with with less size. That is called compression application layer. So that is the uppermost layer and the last layer of OSI model. It is also known as user interface, right? And it provides services such as email, remote management. So that is called user interface layer means always user interact with this layer. Means we are connected in a network. So we are using, means I am using and you are also using this user interface. And responsibilities of this layer is first is FTM. FTM means is always when you use your network. That time what you will do? You will file transfer, you will file access, you will file manage. That is the responsibility. Means on this layer, using your application, you can do that file transfer, access and management. Mail services. If you are using any type of mail services like mail forwarding, mail storage, so you are using this application layer. Directory services means this layer provide access for global information about various services. Global information means over the internet if you are accessing something. If you are accessing your Google, accessing on Google, you are something searching something, or if you are using any website, or you are using your Google Drive, or you are using cloud, that is called directory services. It's over the internet, if you are accessing global information, that is called directory service. So that things you can do that on application layer. That is the responsibility of this application layer. Right? So this is all about this OSI model.